What is going on YouTube? It's StarCoding here to shine light on some code. Today we're going to be talking about arrays. And I already know the only reason why someone's going to be looking at array videos is if you have an interview lined up or someone is asking you about arrays and you need to know some information about them. So let's just jump into it and talk about what you need to know for tech interviews, for just general knowledge, arrays. Arrays. I hope that you're here just to get a quick summary or maybe a quick touch-up of what an array is, because if this is just new information to you, I'm sorry, but oh my gosh, you better reschedule that interview. We got some work to do. But an array, it is a block of memory. It's a block of storage to store a collection of objects. I say collection because, the word list, the word, set, is interchangeable, but a collection of objects, it could be your generic types, like a car or person, something you made. It could be a primitive type, like an integer, a double, a string, character. It could be a bunch of things. What makes arrays awesome is that they are block memory that's stored directly in RAM. It could also be the cache, the hard drive, whatever it may be, but it is stored together. It's not going to be broken apart, stored in other places like a list might be, like a linked list might be. It's all together, and it's parsed by an index going from 0 to n, where n is that max character, and technically it'd be n-1, just because we start at 0. But we got sizzlers, guys. Sizzlers, that's the word. I had to look up an 8-character word just to put in there, but that is the word we're choosing, and that's going to get stored right in DRAM. And so what makes that awesome is that because it's all together, we can insert in constant time, we can delete in constant time, but the only drawback is this clump of memory. It's just that there is no really way to correctly index it on the spot. You have to know what that index value means if you want to find it instantly. If you just have a list of, names, hopefully you have some way of sorting it, some way of putting it in alphabetical order, because if not, you have to kind of search that entire array to find the particular name you're looking for. There's no way to just instantly find it. You have to look through the entire thing. So that would be, O of n. However big the array is, you have to search from, that starting element to the end element to find it. This can be optimized with, a binary search algorithm, an algorithm that kind of breaks it and kind of tries to conquer and divide your algorithm to, find that element you're looking for. The creation is going to be O of n as well. So if we're creating an empty array, it's going to be constant time. It's going to be super quick. But if we are creating a list that has 100 elements, you have to create all 100 of those elements. So it's going to be an O of n creation. So that's kind of the main gist that we need to know for the metrics of this guy. When it comes to some tips I want to talk about, if we could imagine real quickly a bullet point 0 here, one tip is that I know this video is about arrays, but an array could technically be, a hash map, or it could be a string. So any strings out there are pretty much going to be arrays. A string is a, list of characters, those characters being the indexes that make the string, the word, and that list of words is a sentence that is also an array. So if you ever have a problem that's talking about strings, talking about some string manipulation, it's probably going to be a form of an array question as well. They're synonymous, essentially. As well as the hash map, sometimes you might want to be clever and use a hash map, but if you can predetermine what the indexes of your elements are going to be, is there really a need for a hash map? The hash map's there so that way you can quickly find stuff, and there are videos out there explaining this, not in this video, but just keep that in mind. So one thing I want to bring up is appending correctly. if we look at some lines of code, and let me just zoom it in. Oh, wow, that is way too zoomed in. We'll zoom it in here. We have a pretty big list, and we have a new list that's empty. And I want to concatenate a new list based off of all the elements in this big list. So I'm basically just going to remake the big list in two different ways. And the first way is kind of, you might look at this and you might be like, okay, that is an interesting way of doing it, Jake. And it is an interesting way. Essentially what we're saying here is we're saying the new list is equal to the new list plus the next value, the next element in the big list. So we can imagine this is taking the old value plus an individual new element and creating a new list from that. And I know this is weird looking-ish, but you could, if this was a string instead of a list, you could kind of see how this might be the word, and this would be the old word, and you're kind of adding that individual character. So that would be the way that you make a new word. So notice the equal operator, and then notice here in this second way of doing it, all we're going to do is use the append operator, the append method, to append the string onto the list. So here, creating a new list each time, and here, simply appending. Which one do you think is going to run quick or run faster? We'll give it a little run real quick. And you can see that that method too is extraordinary. It's pretty freaking quick. It's 100,000% quicker than the method one. And that goes back to that issue of, you know, creation versus insertion. You know, we have a creation that is O of n and insertion that is constant time. So when I'm inserting here, it's extremely quick. But as, you know, this list gets bigger, we're going to 30,000. As this list gets bigger, this operation is so expensive each time you're making a new list. So just one line difference in how you append things together can make a huge impact in how your program runs. I don't think that y'all will fall for this, but just wanted to point it out for the new faces. So let's go back to our whiteboard. Tip 2. One of the second tips I want to talk about is not forgetting that you can always sort the array / string that you're talking about. It can be done relatively quick. I mean, if the problem's complicated, if we call a merge sort or a quick sort on the algorithm, we're talking about an n log n time. It's not the end of the world if you have to do that. And for example, one of the popular questions out there is find a permutation in the string, and a permutation would be like swapping of a letter would equal it. So for here, we have God and dog, and here I could clearly swap the D and the G, and I would have the same word. So that is a permutation essentially. Point being, if instead of really thinking hard about this problem, how am I gonna do this? This is gonna be some crazy array operations. Well, we could just check, hey, is the length of the array the same? And then after that, just sort all the characters in there and iterate character by character. And you could see here, oh, that is a great way of solving some of those problems. So whenever you're stuck and you're thinking ooh, this looks a little challenging, how I'm going to do this, always know that you can, sort your array. Thirdly, start from the back if you need. Sometimes when it comes to inserting, when we're inserting or we're doing some array operations, you might be wondering to yourself, dang, am I going to hit the back of the array and have an array out of bounds issue? That's always a scary problem. Or am I having to recreate my array each time instead of naturally appending at the end? If I'm having to maybe do some jumps here and there, and you're just you're basically recreating that array in the first problem, you can start from the back. Simple as that. When you start from the back, you kind of just work your way down, and it's very easy to know when you're going to hit the end because instead of finding this arbitrary length value, once you hit 0 or -1, it's like, okay, we're done. We're not going to insert anything else. So those are just, you know, my quick tips and a quick rundown of how arrays are in the tech interview world. If there's any other tips, any other things you think I missed on this video, please feel free to comment below. And as always, thanks for watching.